And for our last example in part 3 of section 4.1, we're going to talk about a linear depreciation problem. These are fairly typical in the business world. When you buy equipment, you depreciate its value over time. Why would you need to know what the value of the equipment is? Because you have to declare it on your taxes. So yeah, kind of real world here. Suppose a company has just purchased a brand new computer for $5,000. The company chooses to depreciate the computer using the straight line method over 4 years. Assume the scrap value of the computer is $0. First thing they want us to do is to graph the linear function. So what the heck does all that word mean in terms of a picture? So when we go to graph this, we're going to recognize that we're dealing with time as the horizontal axis. So our input value is going to be time, or the age, or the number of years that we've owned that computer. The y-axis, the vertical axis, is the actual price or the value. So value, again, that's going to be in dollars, and that will be our y value. So what do we know? Well, from the information they gave us, at time 0, when we bought that computer, it was worth $5,000. So we have a point up here at 0, 5,000. We also know that we're going to depreciate its value over 4 years. And at the end of 4 years, its value is 0. So its scrap value is $0. They can't get anything out of that. So that could change, but for this problem, it's 0. And it's a straight line. So there it is. So there's our graph. So pretty straightforward. And because we have that graph, we can now go in and find all kinds of information about this information about this graph. And so part B is asking us to write a linear function that expresses the book value of the machine as a function of its age. Well, in order to write that linear function, the first thing we're going to need is the slope. So to do part B, let's go find the slope. So the slope we know is that y2 minus y1 over x2 minus x1. So that's going to be 0 minus 5,000 all over 4 minus 0. So that gives me a negative 5,000 over 4, which equals a negative 1,250. Now what that is this is the decrease in value per year. So each year we own this computer, it's decreasing in value by $1,250. So, but that's our slope. But they're asking for a linear function, so now we need to write the equation. So again, we'll go back to f of x equals mx plus b. We just figured out the slope. It's a negative 1250. And again, we know it's negative because we can see the lines going downhill. Plus the y-intercept. Well, they gave me the y-intercept at 5,000. So it's probably the easiest line we'll ever write in our class. So f of x equals a negative 1250x plus 5,000. Great. For part C, they want to know what's the book value of the machine after 3 years. So they're giving me an x value of 3. They want me to find f of 3. So we're simply going to plug 3 into our wonderful function. That'd be negative 1250 times 3 plus the original $5,000. And if you do that, you're going to end up with 1250, which kind of makes sense because that's how much it's decreasing each year for 3 years. So sure enough, that's its value after 3 years. And finally, part D is asking us, when will the machine be worth 2,500? So they're giving me the output. The 2,500 is the value. We're going to set that equal to our function and solve it. And again, you may be able to do this one in your head. If I move the 5,000 over, I'll get a negative 2,500 equals the negative 1250x. Then we'll divide out the 1250 and we'll see that x is 2. So in 2 years, it's lost half its value. And that's a linear depreciation problem. Pretty straightforward. On the homework, just as a comment, you're also going to find some profit problems that give you the revenue and the cost. So just a gentle reminder that the profit, well, let's write it in words. So profit is your revenue minus your cost. So they're going to give you the revenue function, the cost function, and you subtract those two in order to find the profit function. Be very, very careful when you're subtracting. Make sure you distribute that negative sign. And that wraps up section 4.1. We're all about linear functions.